So in this lecture, I'm going to be talking about a very beautiful article from IBM, which is called Zero-Shot Entity Linking with Less Data in 2022. And this is a positive sample. It's very related to that. The idea is that we propose neurosymbolic multitask learning to bridge this gap. Our approach boosts the Blink's performance with much less data by exploiting an auxiliary information about entity types. Because in the previous lecture, we only focused on descriptions of entities. But for example, in biomedical text, we have UMLS ontology that we also have the types in this ontology as well. So why not using entity types as well? So we train our model on two tasks simultaneously. Both the entity linking and hierarchical entity type prediction, which is can be seen as an auxiliary task. So this auxiliary task exploits the hierarchical structure of entity types because it's like a tree. For example, findings is related to other types and that one to other types. So why not using this information? So this is the way we train it. We train for mention, for entity, and type. So for the sentence, she noticed a jaguar speeding on the highway, we have this mention, for example, and this entity jaguar cars. So a typical model for zero-shot entity linking is a scoring function. For any given mention, it introduces a score for that entity. And we predict the entity type. So we have a probability score for each type class. For type class TJ, this is the probability that given a mention, what is the probability that, for example, we have a type equal to founding. And this is their approach is called any-SLET or Nestle. And so they are following models of probability of entity given mentions where VM and VE are vector representations of mention and entity. So the idea is very interesting. Do you know what? Because the probability of higher level parents should be higher than the lower level children. And they just use this constraint. They define it like this, that the probability of TJ is equal to this one, the maximum of T, but T sub K is in the set of all children nodes. And you got the idea. So this is the probability of your type given your mention. And for training, we just use the loss of zero-shot entity linking as well as the loss of type, because for each mention we have a type. So this type, as I said in the previous slides, is an auxiliary loss that we also need to handle. So why not adding them a linear combination of these types, these losses, so that our general loss, we need to just minimize our general loss. And for inference, we have a mention, then the trained entity linking model is used to predict entities in a ranked order. So we have a mention, this mention, and the goal entity is Washington State, and we have top 3 predictions. It could be Seattle with 0.454, and it could be Washington with 23%, and so on. And you got the type for Seattle. We predict that it's, for example, a city. So the entity path probability is computed like this, that if it is a leaf node, is not reachable from any valid type of E, and if it is a leaf node of path J, is reachable from some valid type, but a direct child of T sub K not lying on the path sub J is also a valid type for E.